In this video we're going to quickly walk through what Stack looks like from the point of view of students. We'll first look at this introductory quiz, which we've added to quite a few modules just to give the students an introduction so they can get used to how Stack works. First question, what's the answer to life, the universe and everything? Well, let's try 41 for example. And tells us the answers that's not quite the right answer and directs us to the work of Douglas Adams. So after we've carefully read that, we understand the answer is actually 42, and it will tell us that that's correct. Notice here that we did there's 1 mark per question, and we've got 0.9 marks for this because we answered it correctly on the second attempt, and you get a penalty of 0.1 for each incorrect attempt. Question 2. I'm looking for a statement of Pythagoras' theorem. Notice this has a standard link that we've attached here, how to enter your answers. Let's just have a look at that. So, we won't go through it in detail, but there's a couple of pages of stuff about the syntax for entering mathematics in Stack. Okay, so here, we can enter square root of a squared plus b squared, and it's nicely formatted for us like that. But we didn't read the question carefully. The question asks us for a formula for c squared, not a formula for c. So we get this message down here that explains that that's the problem. So we can you can go away and try that. But let's put in a different mistake. Okay, well that was we do it with invalid syntax with mismatched brackets or something, and we'll get an immediate message for that without having to submit it. But now let's do it like this. So this is right, except that we've done a capital A instead of a small a. And again, this particular question is set up to give feedback on that. It tells us the answer involves capital A, not considered to be the same as small a. Okay. So we fix that up. And now we've got the correct answer. We had 2 incorrect attempts, so we've got 0.8 for that. Similarly, Einstein's most famous equation. And if we haven't bothered to read the instructions on how to enter answers, we might just type E equals mc2 like that. And this question again is set up to explain the syntax. So it tells us here the mc2 is treated as a separate variable with a 3-letter name. And if we want to enter m times c squared, we have to do it with a star and the usual caret symbol, so like that. So now we get a different message which tells us about the difference between lowercase e and uppercase e. So you can fix that up. This question has this test has a couple of pages. We can actually, if we want to see the little menu, you can click it up there. Then we can see there's 5 questions, 3 on the first page, 2 on the second. Click here for the second page. So this is a picture round, which follows a picture of Sheffield. So let's click somewhat randomly like that, and we'll submit. And we've got a fairly standard framework for dealing with multiple response questions like this. So the marking logic will go through and it'll find the first item that we've misclassified, which is this picture here, and it will give us a little message about that first item that's been misclassified. With a little explanation. This is actually Mordor and not Sheffield. Okay, and it points out that there may or may not be other issues with our answer as well, which of course there are, because we've failed to tick these 2 which are also Sheffield. We correct that and maybe think a little bit more about it, and we'll notice that that's actually Sheffield. But it still gives us another error message that now we've correctly classified the first 4 items, we've misclassified the last one, gives us an explanation of that. So we tick that, and now we've got the right answer. And then similarly, the last one, this is just a multiple choice question with a single right answer. So we tick Henderson's, and there we go. And we can check every answer as we go along, or we can just wait till the end if we want and just click finish, submit all and finish. You have to confirm a couple of times, and so now it tells us we've at least got all the answers correct finally, but we had some penalties, so we end up with a mark of 8.6 out of 10. Okay, so that was this introductory quiz with no mathematical content really. Now we're going to go on to this examples quiz, which is a collection of examples to illustrate all the sorts of things that Stack can do. Okay, so this is just one question per page. So this is a differentiation question. If you access this quiz, you'll see that there's each of these questions has some explanatory text attached to it. As we'll explain elsewhere, each of these questions is specified by a markup file, which we can see here. So this is the file that specifies the question we were just looking at. Elsewhere, we'll have a detailed explanation of syntax for that. Here, yeah, so well, actually, just another quick look at that. I mean, the key point here is that there's this function here, diff problem test. So that's kind of quite a fancy function that's in the Maxima library associated to Stack. It's a general marking procedure for differentiation problems, and this will kind of detect a bunch of standard mistakes in differentiation problems and give feedback on them. So let's do the standard mistake here. So we've got the product rule. Obviously, you need the product rule, but the obvious mistake is to just differentiate the two terms and multiply them together. So that gives us cos x over x. And that's one of the standard mistakes that the marking procedure is looking for, and it provides automatically an explanation why that's wrong. Okay, so here I've got a problem about finding critical points for a function in one variable. So let's say there's going to be a local minimum at 0, that's correct. And let's say that there's a local maximum at 1, which is incorrect. Okay. And we do the marking procedure again. This we look at the marking procedure as most of the content is in this invocation as one function here, check critical points 1D, which and so that so that's the thing that works out you just need to tell that which function you're looking at basically, and then it will do the whole marking thing. And in this particular case, it tells us that there is a critical point at 1. Says you said there was a critical point at 1, which we did, but that's not correct. And it gives a little bit of explanation what it means for that not to be correct. Okay. And although we won't immediately see it here, the code for this for these kind of critical point questions will also generate a full worked solution, which we could show to the students later. So here's a two-dimensional critical point question. So let's just so it's not really a fairly standard problem. So I'm going to put in the correct critical points, but let's give them the wrong type. And so it tells us here, we said there's a saddle at -1, 1, which we did here. You said -1, 1, and that's a saddle. And it tells us it's correct that there is a critical point at -1, 1, but it's not a saddle. And once again, this standard library code that will generate a complete solution for this problem that we can show to the students after the quiz is closed. Again, integration. We've got a function that detects a reasonable class of standard problems. So obviously one of the standard mistakes for integrating cos x squared is to say it's cos x cubed over 3. So in the feedback, well, the first thing it says is it just sort of differentiates our answer. Of course, if this was the right answer, then when we were differentiated, we would get cos squared. So the first thing it does is to explain that if we differentiate this answer, then we don't get cos squared. And then it gives an explanation, an attempted explanation of why the method used is not the right method. So here we've got a differential equation to solve. Let's just do so we're supposed to be solving a differential equation with some boundary conditions, and it turns out that this particular function I've written here, it's a correct solution for the differential equation, but the boundary conditions are not correct. Right, let's go here. So actually here, so I mistyped it, so that's why it's telling me that the differential equation is not satisfied. So we'll try again. We need to have a minus sign here. So I put the minus sign in there and check it again. Now the differential equation is satisfied, and it's checking the initial conditions and showing that the initial conditions are not satisfied. And here we can have a look at the markup thing, and so we've got a bunch of code here that does the marking and checks checks whether the equation is satisfied, whether the initial conditions are satisfied, and so on. We'll skip over that one. Here's a question about converting things to a partial fraction form. So we've got a library for this, which is so the library for this is sort of partially developed. It's not really quite in as good a form as it should be at the minute, but it will do some stuff about working with partial fractions. Particularly here, it will tell us that we've got the right general form for the partial fraction. It could be a constant over x minus 2 plus a constant over x plus 1, but we've got the wrong constants. Okay, so now we've got another multiple response question. We've got multiple response here, so we've got 1, 2, 3. We've got seven options. And you might think it's kind of not such a great idea to have that many options, but in fact, these questions with many options, up to 10 options or so, they seem to work reasonably well. The students get through them in a reasonable amount of time, and they seem to learn some stuff by doing so. So let's. And there's two different kinds of feedback that we can provide for these kind of multiple response questions. So one that we quite often do when we've got a large number of options like this is we just tell the student how many options they've misclassified. So in this case, let's tick 2 options which are correct, but there's actually a couple more options that are also correct. And it will tell us that. It tells us all the answers you ticked are correct, there are 2 more answers that are also correct. And so we have to keep on trying. And in fact, experience shows that the students, they will carry on trying until they've actually got it right. So here's another one of the other type of feedback, which we saw before in the introductory quiz, where the marking procedure will give an explanation of the first misclassified option. So here, let's say that we've got this H as identity in the transposition 1, 2, and is it a subgroup or a quotient group of S3 or whatever? So let's say that it's both a subgroup and a quotient group here. Oh yeah, and I should say, we've set up this question so as to show the feedback that's given for every every option. There's a kind of, this is a sort of debugging mode that we quite often use when developing questions to show this little table within the body of the question. Of course, when the quiz is actually live, then we'd remove this table. The feedback for this, we've actually misclassified the first option. We said that H is not isomorphic to a subgroup of S3, to a quotient group of S3, and it is actually isomorphic to a quotient group of S3, so we see an explanation of that. This question's not working correctly in a minute. Okay, and then here's another thing that relies on a kind of slightly fancy library of code. This library of code that's designed for illustrating examples of maps between finite sets and whether they're injective or surjective or whatever. So let's claim that this function is surjective. So actually it's, in this case, it's just telling us that's incorrect. We need to so if we say that it's injective, well, which is correct, then it actually gives us a little explanation of it as well, a little picture to show it's injective because the arrows don't converge, and it's not surjective because the element 3 is not hit by an arrow. Finally, we've got one of these questions which is about writing proofs. So we've got a bunch of questions like this where students are asked to write a proof, but we're given a kind of menu of phrases which they have to. Well, in this particular example, all the phrases are required, so you just have to put them in the right order. In some other examples, there's a bunch of some phrases that are required and some are not, and so you have to choose the correct subset as well. So that's the sort of thing that students fairly typically do. So here's an attempted proof by induction of this fact here. And we get so we get an explanation, right? So here we said statement P1 says that S1, but we haven't actually explained what statement Pn is, right? We should really have started with this phrase labeled 2 here, which explains what's the statement we're trying to prove. So we didn't do that, so this first statement here is meaningless, and we get a complaint about that. So if we try again, so now we've explained what Pn is. So now, right, we claim here in step 4 that we've proved the base case P1 and also the induction step, but we didn't actually prove the induction step, so we get a complaint about that here. And so the kind of questions, it does take some work to set up the rules for marking. Here, this block here, this is all the rules for marking this question. Once you've done it, then you can mark hundreds of students' attempts at proofs with no extra effort. And so so that's a good survey of the types of things you can do with Stack. And then there'll be some other videos which are about how you administer Stack courses and how you develop questions.